See, this is the next center of mass, how you can understood with the help of two particle. Before it was four particle system, now it is two particle system. The distance between the particle is how much? D. Suppose center of mass is over here, and this only x coordinate will be there, there will be no y coordinate because it is a linear position. So what we'll write? m1 x1 plus m2 x2 upon m1 plus m2. So this will be the x coordinate of this. So m1 xy, m1 x1, what is the distance? m2 d, and summation m2 d2 is equal to sigma mi into y, that will become 0, sigma mi zy, that will be z axis, and y axis both will remain 0. So only x coordinate will be there. So it will be how much? It will be m2 d upon m1 plus m2. Understood or not? So this is all about what? Center of mass. But suppose you are having group of particles. Suppose you are having center of mass for several group of particles. Now several group of particles are there, m1, m2, m3, like this. So what you will do? X coordinate, simply what I will do, summation of all particles along x-axis divided by total mass of this system. Summation of all particles along x-axis upon total mass of the particle. This you can do. And suppose it is in y-axis also. So in y-axis also what I will do? m1 y1 m2 y2 m3 y3, as many as particles are there, and divided by total mass, divided by total mass. So this is all about what? Center of mass. So he's saying if we know the center of mass of a part of the system, and their masses, so we can get the combined center of mass by treating the part as point particle placed at their respective center of mass. It means if you know about the part, so you can find out the total mass of the system. Next, which is very important, now till here I taught you only about the point particle, but suppose there is a continuous body. It means now it is not found in term of m1 m2 m3 m4 like this. So what is this? It is a total mass. Understood? Suppose you are having this pencil. So this pencil is having continuous mass. I cannot say it is particle m1, it is particle m2, it is particle m4, like it is not divided in the particles. So it is the continuous mass. So for this point I have to take its x-axis, y-axis and z-axis. So in this case I cannot do summation. So in place of summation I will do the integration along x-axis, along y-axis and along z-axis. What I will do? Summation of all coordinate x-axis, y-axis and z-axis. Suppose I have to find out x coordinate. So this is 1 upon m reciprocal of the mass into integration I will do. In place of summation it will become, for continuous body it will become integration of dm, that is a small mass, into x, along y-axis reciprocal of m into integration of y into dm, z is equal to 1 upon m into dm. This is very important. So he is saying that we do not talk about the ith particle, rather we talk about the small element of the body having the mass how much? Small dm. So I will take the small dm mass, which is x-axis, y-axis and z-axis accordingly. If x, y and z are coordinate of this small mass dm, then we will write the coordinate of center of mass like this. So x, y and z are the coordinate of this small mass. So I can write the position of center of mass along x, y and z axis. So it is very important, the integration is to be performed under the proper limit. It means finite integration we will do, not infinite, because there will be a constant. So for finite integration we will just integrate it. Variable goes from limit, the element covers the entire body, and method of the 3 example I am just explaining to you one by one. So example number 1 I am telling to you first. Example number 1 is, suppose you are having a rod, uniformly distributed mass or uniform straight rod you are having. Understood? So you have to find out its center of mass. It is having only what? X-axis, no y-axis is there because it is only straight rod. It is not lamina which is having x and y axis. So what will be this? Suppose I had got a small dm mass over here which is having distance how much? X from here. So what I will do, I will just first I will find out center of mass for this, then I will integrate it from 0 to what distance? X distance. Understood? What is the length of this rod? That is called length, L. So according to the definition of center of mass, because only x coordinate of center of mass will be possible here, reciprocal of mass into integration of x into dm. This is the general formula. But question comes, how you will write the value of dm? So small mass. So how we can find out mass? What is the total mass of this rod? capital M. You know total mass of this rod is capital M. So how much mass will be there in this dx length? Understood? So that is dm is equal to mass per unit length. You will find out because it is uniformly. So unit length mein mass kitna hoga? Mass per unit length, that will remain constant into dx. So this is the value of a dm. So small mass dm is equal to mass per unit length into dx. M upon L, that is constant, so I will take it outside the integration. So m and m will get eliminated. So what is left? Only 1 upon L. So what is left here? Integration of x with respect to dx from 0 to L. Why 0 to L? Because it is assumed to be 0, and what is the length of this rod? Capital L. So I will integrate it between the limits, so it will become L by 2. Understood or not? That will become L by 2. So where will be the center of mass? Center of mass will be the just at center of this rod, L by 2, because it is uniformly and continuous mass distribution over this rod. There is no z axis, so z will be 0, and there will be y will be also 0. So this is the center of mass for uniformly straight rod. Thank you. Next, I will tell you about the another example.